So as a continuation from yesterday, remember we learned how to graph using the slope and the y-intercept. Today, it's the reversal of that, meaning you are going to be giving points, you are going to be giving slopes, you are going to be giving a graph. And in turn, you are going to be able to take what you have and convert that into an actual equation in the slope and intercept format. And let's describe what we're going to be doing today. We are going to be writing, assuming I can write it correctly, equations in this format. And we know what this is called, right? What is that called? The slope intercept format, right. So we know what the slope is, we know what the y-intercept is. All we have to do is actually identify those two things. But let's do a quick review before we begin to start. Yesterday I gave you something like this and asked you to graph it. Now how would you start to graph this particular equation?
Anchor point.
Okay, first find the anchor point. In this case, the anchor point is your y-intercept, and the y-intercept here is 0, 2. Notice I spot that right away because that number that does not have a variable next to it, that is your y-intercept, okay? And this number right here in front of your input variable is your slope, and it's -3. How do I write this as a rise over run?
-1.
Okay, so -3 over 1, so in that case I am going down 3 and right 1. Very good. So here's my graph. I would go ahead and locate the anchor point, which is 2 up, right there. And now from the slope, I will go down 3, which is 1, 2, 3, and I'm going to go 1 right. And let's say I want another point up here somewhere. What would you do to get a point on the upper corner? Yes? Up 3? So opposite, right? And? 1 left. Very good. So up 3, 1 left. You got yourself 3 points here, and they kind of connect. I know it's not perfect, but there you have it. A lot. Okay? Any questions so far on what we did yesterday? Okay, and you just want to make sure you understand this as well. Now, let's pretend I have this, and I asked you to graph it. What's different about this particular equation? Well, you notice that's quite different from the rest. Yes?
Isn't it an input? The slope?
So it's missing a slope and an input, right? Is that true? So if you're missing that, can you actually tell me if these are the same? Are these two equations the same?
Yes.
That is actually a 0 right there that I'm writing. Are these two the same? Okay, why? Good. 0 times x equal to 0, so 0 plus 3 is still 3, so they're basically the same. Why is it that I want to write in the other format? Because what I'm trying to prove here. Thank you so much. That since the slope here is a 0, and we know that a 0 slope means that we have a horizontal line, like you said, and we do have an anchor point at 0, 3. So I'm going to go and graph that right here, and I expect to have a horizontal line, therefore I just go ahead and draw a line right through that anchor point as a horizontal line. When will I have a vertical line, do you think? Look at what I have as a format. When I have an equation looking like this, where the x is missing, I have a horizontal line. Now use that concept and tell me, when would you expect to have a vertical line if I asked you to graph? What will have to happen if it's going to be a vertical line? Any guesses on that? Yes, Mark?
It would just be y equals x.
But if there's x and y together, you have a diagonal line, remember? Right? Because if you have an x in there, there'll be a slope. A slope will give you the steepness of the line. So the steepness of the line. So there should be an x. But so when do you expect to have just a vertical line? Okay, so if you have y and x in the same equation, you have a diagonal line, whether it's upward or downward. If you're missing an x in your equation, it's going to be a horizontal line. What equation would give you just a vertical line?
You're missing a y?
Missing the y. Thank you. So all you have to do is the reversal of that. I would actually give you something like this. Notice it's missing a y. So if I was to graph this, you would end up having a line going right through the x-axis at 3, vertical line. So please, you got to take notes on this because it's important you recognize the differences of missing an x and missing a y. Okay? These are the two important cases here that you need to remember. When do I graph a horizontal and when do I graph a vertical? Okay? Are we clear on this? Okay. So to start us off here, I want to do something quite simple. So pretend that I have this. Let's pretend I have a slope of -2, and I also give you a point of -3, for example. What did I just give you? A slope and
Intercept.
anchor point. It's just not just any anchor point. What is that point specifically?
The y-intercept.
The y-intercept. How do you recognize it to be the y-intercept?
Because there's a 0 in the x coordinate.
Thank you. Because of this 0 right here. Every time we have the 0 in the x component, we know that it is the y-intercept. So I just gave you the y-intercept. I just gave you the slope, right? And we know the y-intercept is actually b, isn't it? Right? So if I ask you to write an equation in slope-intercept format, the first thing you write is, what does the equation look like? You got to have a format first. So I'm just going to go ahead and write it out for you. And you need to remember this. My equation looks like this. In order to write it, I just need two things. The slope and the y-intercept. And you ask, do I have those two things? I do. I have the slope of -2, so I quickly replace that m with -2. And I also have the y-intercept of -3. So I quickly replace that b with -3, and then the rest will stay in its place. And there you have it. I'm done. That's how you write an equation in a slope-intercept format. See it? And you might argue, wait, there's a plus sign here. Yeah, you're right. Look, isn't a plus minus becomes a minus anyway? Yeah. So you still end up with this. So there's your slope, there's your y-intercept, based on what I just gave you. And that's how you put back. Notice that the x and y are just open variable because these are the input and output, right? You're going to wait for the input to get the output. But the two fixed value that you have will be plugged in to fill into your equation. Okay? Please, if I ask you to write an equation, this is the format that I want you to write it in. You should replace the slope, you should replace the y-intercept, not x and y, once you are done writing the equation. Now here's another variation that I need to bring up. So this is the first variation. The second variation looks like this. Let's pretend that I give you a slope of -5, and I give you a point of 2.7. Make it -2.7. Okay. If I ask you to write this in a slope in a format, immediately you should do what should you be doing? What do you want to look for if I want you to write in the slope in a set format? The y-intercept and the slope, right? Right now you have just the slope. I look at this point right here and I'm asking, well, is that the y-intercept? Is that the y-intercept? No, it's not. So I have to find the y-intercept. Is that true? Before I can actually complete my equation? So to find the y-intercept, once again, you always start with, what is it that I want to write it in? I want to write it in the slope-intercept format. I gotta have a starting point. This is my starting point, and it's also my ending point. I'll show you why in a minute. But look, this is what I have. Look at what you already have right now. What do you have? A slope and a point. Is that right? Watch. I can quickly replace the m with the slope, isn't it? Which becomes -5. Look what I'm going to do next. I do not know what my y-intercept is, but I know one thing. I know that this is a point. And a point is made up of x and y. And I also have x and y right here. Guess what I'm going to do with the x and y?
Plug it in.
Yeah, exactly. So you can take the -2, plug into x, and I take the 7, plug into y. And what variable do I have left? Just the b. And is that what we're solving for? It is. So let's solve it. You got 7 over here, you got 10 over here. How do I solve for b now?
Subtract 10.
Subtract the 10. Subtract the 10. You got b equals to -3, right? So look, let me circle a couple things to show you. I got my b, I got my m. Look at my starting point. Remember I told you my starting point is also my ending point? So my ending point will look like this. Y equals to, what am I replacing only?
-5.
-5, because that's a slope, and the y-intercept is? There you have it. That now is your equation. Done. What do you think of that? Any question on that? Are you sure? No questions? Okay, all right. Let's move on to the third scenario, and we'll be done with it. Right, Lauren? Okay. Here's the third scenario. The third scenario is a little bit more challenging, but it's not like too difficult for you to work on. The third scenario involves something like this. Pretend now that I have 2 points instead of 1 point. So let's see if I can get this right. Let's do that. -2, -5, 3, 5. I have 2 points, and I give you nothing else but 2 points, and I ask you come up with an equation in a slope intercept format. So the first thing you should start is, what is the slope intercept format, right? Let's write it. Can anyone tell me what the slope intercept form is? Thank you. So you should, at this point, be able to say y equal to an m times x plus b, and notice that I don't have my slope this time. I don't have my y-intercept either, so I cannot fill them in. So immediately I should think about, I need to find the slope. I need to find the y-intercept. But the slope is the most important thing for a line. Because if I don't have the slope, I don't know if the line can be horizontal, vertical, upward, downward, right? So find a slope. How do we find a slope given 2 points? Subtraction. So look, the slope is quite simple. Set it up as a subtraction problem. -2, -5, 3, 5. Subtract, subtract. Question there. Let's subtract. What is -2 minus 3? Negative what? -5. Okay, this is the most important step right here. Because if you don't get the slope correct, you will not get the equation correct. So check this carefully. What is -5 minus 5? -10. And so how do we put together our slope? Rise over run. Which one's the rise and which one is the run? Thank you. So y here's x here, so you know rise is the y, right? So it's -10 over -5, which makes our slope to be 2. So we got our slope. We got a slope. We still need to find the, what is it that we need to find now? The y-intercept. But wait, didn't we just learn how to use to find the y-intercept from last problem? You need to start from this again, right? Plug in what you have thus far. I have my slope to be 2. What is my x and my y in this case? What do you think? Okay, so here's your problem. Which point to pick? Oh my gosh, 2 points. I don't know which one. Thank you very much. You can pick any. You can pick the first point. You can pick the second point if you want to. It doesn't matter. Because these 2 points are on the same line, you can get the same exact equation. It doesn't matter which point you pick. But my suggestions is pick points that are easy to solve. So I would definitely avoid a negative. Put it in the positive, okay? So 3, 5. Where did I put in the 5? Where's my 5? The y. And the 3? X. There you have it. See that? Makes everything simple. And you have 5 equals to 6 plus b. Subtract the 6 over. You got b equals to -1. So I circle that as well. I circle my slope. I circle my b. How do I put the whole thing back together? Y. Okay, so you start with the y equals 2x minus 1. And that now here, guys, is your equation of the line that's going to be crossing over the 2 points in slope intercept format. Okay. Any question on this particular lessons? Is it straightforward enough? Okay. No, honestly, if you have anything, ask now so I can actually go over it with you. If not, we're going to just call this a day. Can I call it a day? A day?
Yeah.
All right, so be it. We're done.